going to talk about our in-class experiments. Our complex question was, what variables affect magnetic force? We're going to go over the first groups. Their question was, does temperature affect the magnetic force? And their claim was, the cooler the magnet, the weaker the force. And then their evidence was that they measured the force between the room temperature magnets and got 3.3 grams, and then they measured the force between the cold magnets and got 3 grams as well. So they found that whether the magnet was cold or it was room temperature, they got the same amount of force.
The second group also tested temperature as a variable, but instead of testing cold magnets, they tested a room temperature magnet as their initial, and then they heated the magnet. So their claim was that the higher the temperature, the stronger the attraction. So they tested the room temperature magnet and they got 7.2 grams, and the heated magnet they got 7.6. So they really didn't see a significant difference either.
The difference between this had to have been an error that it should have been the same amount of grams force, but the reason why I think there was an error here is because with the ruler they had it hovering above the scale, which could have accounted for a lot of.
We did a similar experiment for our project. We tested temperature as a variable, but instead of testing just cold or just hot, we tested an initial room temperature magnet, then we cooled one magnet and we heated another, and we tested all three of them. We still had the same results. We found that temperature did not affect the magnetic force.
Both these groups and our experiment, we found that temperature does not affect the magnetic force, but we found that's actually false, that the colder the magnet, the more magnetic force there will be, and the hotter the magnet, the less magnetic force. And our professor explained it to us kind of in a diagram. He showed us that in each magnet there's little magnets. In a hot magnet, they go every which way, so the magnetic force is weakened, but in a cold magnet they line up, so it has a stronger magnetic force. But we also found that our cold or hot wasn't extreme enough, that it had to have been extreme temperature. Second experiment that we had our groups do. So this group, their question was, how does the strength of the magnets affect the magnetic force? Their claim was, the stronger the magnet, the further the magnetic force will start. And then what they did is they took two magnets and had a ruler next to the scale, and they slowly lowered it. And once they noticed that there was a change in the grams on the scale, that's when they marked that the magnetic force started. So between two magnets, they saw that it was 3 inches, the magnetic field started. And then once they put 2 on the bottom and 2 on the top, so 4 magnets, they noticed that the magnetic field started at 5 inches.
The other group experiment, their question was, how does size affect magnetic force? And their claim was, the bigger the magnet, the stronger the attraction. They had 2 magnets at 2 inches apart, and they saw that the attraction was 6.5 and it repelled at 7.2. And then they doubled it with 2 magnets on each end with the same distance, and they found that with 2 it was 18.5 and repelling was 22.3. And both the experiments look similar, but they're completely different.
Now I'm going to talk about our first experiment that we did or our first testable question that we did in our own group. And our question was, how does a magnet interact with different materials? We claimed that magnets will attract materials or objects made of metal. It was a really simple and elementary experiment, and we thought that this would be a good experiment to present to the class because at the elementary level we assumed that most students would be interested to find what the magnet attracts and what it doesn't attract. For our third experiment, our question was, is magnetism affected when tested through different states of matter? our claim was that the force would be the strongest through a gas and the weakest through a solid, because the solid would be blocked by something with more substance, so we thought that that would be the weakest. What we did was we tested through different states of matter. We found that gas and solid were very close. The magnetic force didn't change much between the two. But when we tested through water, we had a huge significant difference. So when we brought our evidence to class, we found that this was actually an error. And so I'm going to demonstrate that for you guys. When we first tested with the water, we had almost a full cup of water. So we put the magnet inside the cup and we put it on the scale. And when we dipped the second magnet into the water, we had to actually, in order to get it to the mark on the ruler and make a difference on the scale and show the magnetic force, we actually had to dip our fingers into the water to be at the 4-inch mark. And when we did this, it put pressure on the scale, and so it changed the weight on the scale and therefore changed our readings for the magnetic force. The second time that we tested it, after we realized our error, we used less water in the cup. We have our same 4-inch mark here, and when I was holding the magnet and inserting it or lowering it towards the scale, you can see that my fingers are at the same mark, but I'm not actually touching the water, so I'm not putting any additional pressure on the scale other than the magnet repelling the magnet that's in the cup of water. So the second time that we did it, we found rather than 7 grams, we got around 1.8 grams, so it was a lot closer to the gas and the solid, which is about where it should be. So we corrected the error and we got the appropriate results for this experiment.
Here are some things we learned in our experiments to help us with our teaching career in the future.
First, we learned that terminology is very important to doing experiments or in our teaching in general. We learned that we should take more time with making sure that the students understand the terminology and understand the definitions. We also learned that maybe we should take a different approach when teaching definitions, because the route that we took by just giving them the definitions definitely confused our students. And then the second thing we learned is that teaching takes a lot more planning ahead than we realized. With doing this experiment, we realized that we had to put in a lot of hours thinking of how to do our experiments, what materials are going to use, what we want our students to learn, and that teaching isn't just...
Another thing that we learned was that it's also important to plan out the order of your lesson plan. If we were to do this experiment again, what we would have done probably would start with a basic definition of what magnetism is and what it entails, and then done some smaller macro level experiments rather than diving in and offering up the opportunity to explore on a micro level and using lots of different variables. Also, we would have probably offered less or more specific materials for our experiment, because when we did all of our experiments, we offered up so many different types of materials. So I think that our groups got a little bit confused about what they were supposed to be doing, and they missed out on some other important possibilities that they could have tested, because we gave them something to heat with, something to cool with. We gave them lots of different magnets. We gave them scales for measuring. We gave them different materials to test the magnetism to see what was magnetic and what was not magnetic. So there were a lot of different variables that they could have tested, and I think that they kind of got lost with all those different opportunities instead of bringing it back a little bit and sort of offering up a little bit less so that we could hone in on a specific variable or a couple different specific variables.
In experiments, you want to be as accurate as possible. You want to limit them to 1 or 2 variables only, because when you add more variables, you're going to run into more problems and other things that can cause your results. One thing that we saw was when the class, they had a ruler, and some of them would hold it right up against the table where others were just trying to hold it, and it was just floating there, so it would move back and forth, so they couldn't get an exact reading. Also, like in our water experiment, when we put our hand in the water, that changed it compared to when we just held it over the water.